may want to reference this anchor chart that talks about when to use which measure of center and when to use which measure of spread. So essentially just remember, if there is no skew, no outlier, if you have symmetric data, you're going to use mean and mean absolute deviation. If you have an outlier or your data is skewed, median or interquartile range are your better options. Look at a little bit of data and see what we can determine from it. So it says all of the marathon runners from each of two different categories have their finishing time represented in the dot plot. So we have ages 30 to 39 here, and we have ages 40 to 49 here, and how long it's taking them to finish this marathon. So if you notice, the longer that it takes them to finish, the worse. Like, we want smaller numbers. So you can see from here just that 30 to 39 tend to do a little bit better. They are pretty spread out, but they do a little bit better than 40 to 49, because we can see that 40 to 49 is typically a little bit higher. But as far as specific numbers, it would be really annoying to maybe go through here and find the median by trying to, you know, cross them out and work towards the middle, because there's so many. It would be nearly impossible to find the mean or the average, just because we don't have those exact number values. So what I've done is I've actually calculated those for you, and they're listed here, and we're going to use these to answer a few questions. So we have the mean absolute deviation, the median, the interquartile range, and then Q1 and Q3 in case we need that for each of the data sets. So the first question is, what measure of center, measure of variability are most appropriate to use with these distributions? So these distributions are not very symmetric. They're kind of scattered all over the place, and they don't have a very symmetric shape. So we would actually want to use the median and the interquartile range in order to describe the measure of center for median, measure of variability for interquartile range. Which group tends to take longer to run the marathon? Well, we've kind of already talked about that. The group that's from 40 to 49 in their ages tend to take a little bit longer, because if you notice, those numbers are higher. And then if we look at the group that tends to, so that's usually talking about average. So if you look at that median number for that group, it's higher than for the 30 to 39 group. Which age group has more variable finish times? So what that means is which one is varying the most in their finish times. So if we wanted to look at variation, we could look at interquartile range, and the one that has the larger interquartile range is going to be the one that's varying the most. So that's 40 to 49. Are there any outliers in this data set? So initially we might think that some of these higher numbers, the people who finish slower, takes them longer, might be outliers, but we would need to actually calculate some of that data using our interquartile range. So remember, for example, for 30 to 39, we would take our interquartile range and multiply it by 1.5. You'd actually get 97.5 if you did that. And then you would subtract it from Q1 and add it to Q3, and you would get 162.5 and 422.5 here. So this one is saying that if we have any number smaller than 162, it's an outlier. Well, we don't, because we can see we don't have any numbers past that. If there's any larger than 422.5, which would be right around here, and there is not. So there's not an outlier in this first data set. Now we can do the same thing and track it for the second data set. So I'm going to go ahead and calculate those, and then we'll compare. I found that my lower end number is 151. So I see that there's no number smaller than that, so I don't have any small number outliers. And my high number is 519, and notice I don't have any numbers bigger than that. So there's actually no outliers in either of these data sets. The next question says, how do you think finish times for a 20 to 29 age group or age range will compare to these two distributions? So I'm going to assume that the younger are going to be maybe a little bit more in shape, and maybe they run a little bit faster. So maybe their data is even more this way. I might assume that it'll be less spread out. So you can see that the older they get, we've still got some people who are doing pretty good over here, but then we've got some people who are slowing down over here. So it might be even shorter times and maybe even a little bit closer together. But again, that's just an estimate. So really there's no right or wrong for this question. I want to look at a question about comparing mascots. It says, a new pet food company wants to sell their product online and use social media to promote themselves. To determine whether to use a dog or a cat as their mascot, they research the number of people who click on links with an image of a dog or a cat, and this is the information that they are given. So we've got clicks for images of dogs, we have the mean and the median, and then the MAD and the interquartile range. And then for cats, we have our picture here, but we also have those measures of center and measure of spread. So it says, based on the shape of the data, which measure of center and measure of variability would you use to compare this distribution? So notice that the shape of the data is relatively symmetric. It's not perfect, but it's pretty symmetric. So since these are both pretty symmetric, we're actually going to use the mean to compare the measure of center, and we'll use the mean absolute deviation to compare the measure of spread. So we want more clicks. So you see that these number of clicks are higher. So according to the average, we would want dogs. But if you look, we would want a little bit less variability. So you can see that this has more consistent clicks than this. So we would need to kind of determine, do they want more clicks on average or do they want more consistent clicks? So we want to talk to the food company about that.